Bismillahirrahmanirrahim. My name is Muhammad Ghazali. Today I will solve Cambridge International AS and A Level Mathematics Paper 1 My June 2022. Question number 1. The coefficient of x4 in the expansion of 3 plus x power 5 is equal to the coefficient of x square in the expansion of 2x plus a over x power 6. Find the value of the positive constant. And we have to find the coefficient of x4. Now, the general term formula of the binomial expansion is NCR a power n minus r b power r. And we see that here is n is 5, c as it is, we write r, a is 3, we put here value at 3. Now 5 minus r, b is x, we put x power r. We know that here we have to find the coefficient of x4. Therefore, x4 equal to x power r. That is, it means r will be equal to 4. Now put the value 4 here, 5c4 and 3 power 5 minus 4 into x power 4. Now this is the coefficient. This is the coefficient of x4. Now here we write it, coefficient of x4, that is equal to 5c4 3 power 1. Now 5c4, we know that is 5. You can calculate by the calculator. 5 into 3 is 15. Now we find next coefficient of x square using the same formula here for this expansion, 2x plus a power x 6. Now values put in this formula. Now here is n is 6, c as it is, r as it is. Here a is 2x. Now we write it 2x power 6 minus r, same as here a over x is considered as b. This is the p, and that is power r. 6cr 2 power 6 minus r, a power r into x power 6 minus r, and that is 1 over x, mean x power minus 1 power r. Now 6cr 2 power 6 minus r, a power r into x power 6 minus 2r. X 6 minus 2r is equal to x square. Therefore, there is x square. Now, the r equal to 2, and that is equal to 2r equal to 4, and that is r equal to 2. Now, 6c2, we write it 6c2 into 2 power 6 minus 4 into a power 2 into, that is x square. Now coefficient of x square and the coefficient of x4, where is x4 coefficient? 15, and this is the coefficient of x square. Coefficient of x square, that is 6c2 2 power 4 a square. Now the coefficient of x4 equal to coefficient of x square, 6c2 2 power 4 a square, that is 15 equal to 6c2. We calculate the value of 6c2, 6 2, that is equal to 15. Now we write it 15 into 2 power 4, 2 power 4 is 16 a square. Therefore, a square will be equal to 16 and a will be equal to, sorry, a square equal to a square equal to 1 over 16 and a will be equal to 1 over 4 plus minus 1 over 4. That's the answer. This question number 2, the second and third term of geometric progression are 10 and 8 respectively. Find the sum to infinity. We suppose that AR square is the geometric progression. And here the second term is AR, that is equal to A, 10. And third term is AR square is equal to 8. Now to find R, we divide AR square over AR, we get 8 over 10, that is equal to 0.8. Now R will be cancelled, A will be cancelled. Now R equal to 0.8. We put the value in this first question. Now here is AR equal to 10, then AR is equal to 0.8, and that is equal to 10, and we get A equal to 10 over 0.8. Now we calculated 10 divided by 0.8, that is equal to 12.5. Now find the sum to infinity, that is the formula, sum to infinity A over 1 minus R. Here R is less than 1, we can use this formula. A value, we put the value of A here, 12.5. 1 minus R is given is 0.8. 0.8. Now we get 12.5 divided by 0.2. We get the answer from calculator. Now 12.5 divided by 0.2, we get 62.5. This is the answer. Now go to the next question. Question 3, the equation of curve such that dy over dx equal to 3 bracket 4x minus 7 bracket 1 over 2 minus 4x power minus 1 over 2. It is given that the curve passes through the point 4, 5 over 2. Find the equation of the curve. Now to find the equation of the curve, we have to find y. Now here dy over dx is equal to 3 into 4x minus 7 power 1 over 2 minus 4x power minus 1 over 2. To find A, we integrate both sides, we get that is equal to, integrate both sides, we get y equal to 3 times 4x minus 7 power 1 over 2 minus 4x minus 1 over 2, and we take in bracket dx. Now you know the formula of integration of ax power n is equal to a into x power n plus 1 over n plus 1. And second formula is ax plus b power n of integrate, that is a into x plus b power ax plus b power n into, that is equal to na into n plus 1 plus c. We integrate this 3 as it is into 4x minus 7 power 1 over 2 plus 1 over a is 4, 1 over 2 plus 1 minus 4 into x power minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1. We divide this by the power of x plus c, that is equal to 3 as it is 4x minus 7 power 3 over 2 over 4 into 3 over 2 minus 4 into x power 1 over 2 minus 1 over 2 plus 1 1 over 2 divided by 1 over 2. Now we get 2 to the 4, 3 times 3 1. Now 1 over 2, 4x minus 7 power 3 over 2 minus 8 into x power 1 over 2 plus c. Now we put the value to find c, where is x is 4, y is 5 over 2. Now we put here value y is 5 over 2, 1 over 2, 4 times, here is x, we see x is 4, x is 4. Now put the value 4 minus 7, 3 over 2 minus 8, x is 4, power 1 over 2 plus c. We solve this 1 over 2, 8 minus 7, 1, 1 power 3 over 2, 1. Minus 8, square root of 4 is 2, plus c, 5 over 2. Now we get 5 over 2, 1 over 2, minus 16, plus c. Now c will be equal to 5 over 2 minus 1 over 2 plus 16. To solve this, that is 4 over 2 plus 16. 5 minus 1, 4 over 2 plus 16. That is equal to 18. C will be equal to 8. Now 1 over 2 into 416 minus 7. So for the 16, 16 minus 7 power 3 over 2 minus 8 into 4 power 1 over 2 is 2 plus c, so that is equal to 5 over 2. Now 1 over 2, 16 minus 7 is 9, 9 power 3 over 2 minus 16 plus c, and therefore c will be equal to 5 over 2 minus 1 over 2 and 3 power 2 into 3 over 2 plus 16. We get c equal to 5 over 2 minus 27 plus 16, and we get 5 over 2 minus 27 plus 16. Now c equal to 5 over 2 minus 27 over 2. Here is 27 over 2. Now we write it minus 27 over 2 plus 16. Now we calculate this value. Here we calculate it. C equal to 5 minus 27 minus 22 over 2 plus 16. Therefore, minus 11 plus 16 and C will be equal to 5. Now the equation becomes, our equation becomes y equal to 1 over 2 4x minus 7 power 3 over 2 into 8x power 1 over 2 plus c. Here is c. We put this value in this equation. Now this is the c value is 5. This is the this is the equation of the curve. Question number 4. The first, second, and third term of an arithmetic progression are k, 6k, and k plus 6 respectively. Find the value of the k. Now this is the arithmetic progression. First value is k, 6k, and k plus 6. Each term is obtained by adding a constant value. The difference between two values will be same in the arithmetic progression. The arithmetic progression 6k minus in arithmetic progression, the common difference remains same for each value, and we get 6k minus k is the common difference, and we can write it as k plus 6 minus 6k is equal to the common difference t, same common difference. Now we equalize this, that is 5k, and that is equal to minus 5k plus 6 equal to b. We write it here, 5k equal to minus 5k plus 6, that is equal to 5k plus 5k, 10k equal to 6, and k will be equal to 6 over 10, that is equal to 0.6. Question 4b part, find the sum of the first 30 term of the progression. Now here we have the progression 6k, 6k, k plus 6. Now the value of k is given 0.6. We write this value here, 0.6 into 6 multiplies 0.6 plus into 6 plus 0.6. Now we find the sum of first 30 terms. Here k is equal to 0.6, first term is 0.6, first term, we write first term is 0.6, and we find the common difference b, that is equal to 6 multiplies 0.6 minus 0.6. Now we get 0.6 into 6 minus 1, that is 5, 0.6 multiplied 5, that is equal to 3. Now d is 3, common difference is 3, and the first term is 0.6. Now the formula of sum of arithmetic progression. Now this formula is s equal to n over 2, 2 times of a plus n minus 1 times of b. Here is n is the 30. Now we put 30 over 2 2 of A is given here is 0.6. N is given 30 minus 1, 29. And that D is 0. D is 3. D is given here is 3. Now that is equal to 15 into 1.2 plus 3 from 9 are 27, 3 2 are 6, and 87. Now we calculate the answer. 15 bracket 1.2 bracket plus 87, that is equal to 13.1323. S equal to S30 will be equal to 1323 is the answer. Now we go to the next question. Question 5, part B, given instead that a equal to minus 7 over 2, find the values of k for which line is tangent to the curve. The line is a tangent to the curve means that line touches the curve. Here the line is y equal to x minus y, x minus a that touch the curve, and we equalize these two equations. When the line intersect or touch the curve, we equalize both equations. Now y equal to x minus a, we write it as x minus a, that is equal to y, here y equal to a 4x square minus kx plus 1 over 2k square, we write this and put the value of a. Now that is equal to x 7 over minus 7 over 2, that it would become plus 7 over 2, and 4x square is minus kx plus 1 over 2 k square. Now here we see that 4x square minus kx minus x plus 1 over 2 k square minus 7 over 2 equal to 0. And the question becomes 4x square plus minus k minus 1 x plus 1 over 2 k square minus 7 over 2, that is equal to 0. Here the line touches the curve. Therefore, the discriminant of this equation b square minus 4ac will be 0. Now here the b is coefficient of x is b. Now minus k minus 1 whole square minus 4 times a is 4. C is given here 1 over 2, that is c. 1 over 2 k square minus 7 over 2. We write it as c, that is b, and that coefficient of x square is considered as a. That is equal to 0, and we solve this. This is a plus b whole square formula used here. That is k square plus 2 times k plus 1 minus 16 multiply 1 over 2 k square minus minus plus 16 multiply 7 over 2 equal to 0. That is k square plus 2k plus 1 minus 8k square plus 56 equal to 0. Now plus 1k square minus 8k square, that is minus 7k square plus 2k plus 57 equal to 0. Plus 1 plus 56. Now here we taking minus as a common, that is 7k square minus 2k minus 57 equal to 0, and 7k square minus 2k minus 57 equal to, we can find the value of k by midterm breaking. Midterm breaking, we multiply 7 to 57, we get 399. Now to factorize the 399, we make two factors, such as when we multiply, we get 399, and we subtract this, we get 2119 factor for midterm breaking. 7k square is written as it is, minus as it is, minus and minus 57 equal to 0. We write 21k minus 19k, we get 2k. Now 7k square minus 21k plus 19 minus 19k minus 57 equal to 0. Now taking the common, 7k and k minus 3, then plus 19 minus 19k minus 57, 19 taking as a common, k minus 3 we get. Now here k minus 3 times 7k plus 19 is the answer. Either k minus 3 equal to 0 or 7k plus 19 equal to 0. That is k equal to 3. And k will be equal to minus 19 over 7. The answer is 3 and minus 19 over 7. Question 6. The diagram shows the curve with the equation y equal to 5 x power 1 over 2 and the line with the equation y equal to 2x plus 2. Find exact area of the shaded region which is bounded by the line and the curve. Here we have to find the area of this shaded region. Now to find the area of this shaded region, firstly we have to find the intersecting points of the curve and the line. To find the intersecting point, we equalize these two equations, y equal to 2x plus 2, here y equal to 2x plus 2 and y equal to 5x per 1 over 2. Now that it would become 2x plus 2 equal to 5x 1 root. We taking square on both sides. That equation, that expression becomes 4x squared plus 2ab, 2 into 2 4, 4 2 into 2 8, 8 times x plus 2 to the 4, and 5 square is 25, and x square root of x becomes x. 4x square plus 8x minus 25x, 4x square minus 17x plus 4 equal to 0. Now 4 times 16, 16 into 1 is taking for midterm breaking of 17, 4x square minus 16x minus x plus 4, 0, and 4x is taking as common. Now taking as common, here x minus 4 minus 1, x minus 4, that is equal to 0, and x minus 4 into 4x minus 1 equal to 0. Either x minus 4 equal to 0 or 4x minus 1 equal to 0, and x equal to 4, here x equal to 1 over 4. These are the two values at which the line and curve intersect. These are the 1 over 4 and 4. This point is 1 over, this point is, that this is the 1 over 4, and that point is 4. This is 4. This is 1 over 4. Now we have to find the exact area of the shaded region, which is bounded by the line. When you have to find the area between two curves, curve and line, to using this formula, A area is equal to AB into F1 of x minus F2 of x. Here is two function. One is given as curve, another is line. Now we use this formula to calculate this. Here area will be equal to integrate 1 over 4 to 4. Okay. First equation is a curve. We write as a curve 1 over 5x power 1 over 2 minus, there is the line 2x plus 2 dx. There, now area will be equal to, now we integrate this expression, 5 x power 1 over 2 plus divided by this 1 over 2 plus 1 minus 2x square over 2 minus plus minus 2x, and apply the limits here 1 over 4. So area will be equal to 5 x power 3 over 2, 3 over 2 x square minus 2x. And we put the limit. So area will become 5 multiplied to 10 over 3 x power 3 over 2 minus x square minus 2x 4, 4. We apply the limits. Firstly, we add, firstly 4, we put the 4 in this question, 10 over 3 x 4, 3 over 2 minus 4 square, 2 into 4 minus 10 over 3 x power x. X is 1 over 4 here, power 3 over 2 minus 1 over 4 whole square minus 2 times 1 over 4. 10 over 3, 4 is the square of 2, 2 square into 3 over 2 minus 16 minus 8 minus 10 over 3, 1 over 2 square, 3 over 2 minus 1 over 16 minus 1 over 2. Now 10 over 3 multiply, square will be cancelled, 2 power 3 is 8, minus 16 minus 8 is minus 24, minus 10 over 3, square will be cancelled, that is 1 over 8, minus 1 over 16, minus 1 over 2, divide this, now the value will come 80 over 3, minus 24, that is 2 and 5 is 10, 4 is 5 over 5 over 12, minus 1 over 16, 1 over 6. Now we put the value in the calculator as 80 over 3 minus 20 over 4 minus 5 over 12 This is minus 5 over 12 minus 1 over 16 and minus 1 over 16, then minus 1 over 2. Now get the answer. Yes. We divide this 45 over 16. Sorry, 45 over 16. Question 7. The diagram shows a sector OBAC of a circle with center O and radius 10 centimeter. The point P lies on OC and BP is perpendicular to OC. And OC, here is OC, that is perpendicular to BP using the formula of arc length formula. And the arc length of a sector is equal to 1, that is equal to r theta, that is equal to r theta. Now here arc length is 2 and radius is 10. Then we can find theta. Now here put the value, that is 2 equal to 10 times theta, that is theta will be equal to 2 over 10 and that is equal to 0.2 radian. Here the angle BOC will be equal to BOC, that is equal to angle BOA plus AOC, AOC, that is AOC. Now we write it 1 over 6 pi plus 0.2 radian. This is the answer of part A. Part B, hence find the area of the shaded region BBC. Given your answer correct to 3 SF significant figure. Now we have to find the area of this shaded region. Firstly, we see that this is the sector COB. Now area of this shaded region will be equal to area of sector BOC minus area of triangle OBP. We get the area of this shaded region. Area of sector is given here 1 over 2 r square theta minus area of triangle, here is 1 over 2 into its product of adjacent sides OP into OB and sine of angle between them. This is pi over 6 plus 0.2. Here r is given is 10, 10 square is 100 and theta is given pi over 6 plus 0.2 minus 1 over 2. OP is not there given. Now OB is 10 and that is sine pi over 6 plus 0.2. We see that we have to find OP. This is the right angle triangle and triangle OPB. We see that that is the adjacent of the angle. Therefore, adjacent side OP our hypotenuse, that is equal to cos pi over 6 plus 0.2. We can write OP is equal to 10 times cos pi over 6 plus 0.2. Now to find value of OP, I put the value in the calculator. Here 10 multiply cos pi divided 6 plus 0.2. We get the answer 7.49. 7.492. This is the answer of OP. We write the answer here 1 over 2, 7.49. multiply 10, multiply sine pi over 6 plus 0.2. Now we write it here, 1 over 2 multiply 100 multiply pi over 6 plus 0.2. Now the value, put the value 1 over 2 multiply 7.494 multiply 10 multiply sine pi over 6 plus 0.2. Here we get the answer 24.80. Now here we write 24.80. Now we calculate this 50 multiply pi over 6 plus 0.2. Now 50 into pi over 6 plus 0.2 minus 24.80. And now to find it by, we find this value by using calculator. I put this value 50 into pi divided 6 plus 0.2 minus 24.80. You can see here in the calculator. Now the answer is 11.37. Now the three segment failure value will be equal to 11.4 is the answer. Question 8. The equation of a circle x square plus y square plus ax plus by minus 12 equal to 0. The point A11, B2, minus 6 lie on the circle. Find the values of A and B and find the coordinates of the center of a circle. These points A11 and B2 minus 6 lie on the circle. Therefore, we substitute these points in the equation of circle. Now here is the equation given x square plus y square plus ax plus by minus 12 equal to 0. Now we put the value first 1 therefore 1 square plus 1 square plus a times 1 plus b times 1 minus 12 equal to 0. Now in the second, we take second point 2 minus 6, we take 2 square plus minus 6 square plus a into 2 plus b into minus 6 minus 12, that is equal to 0. Now we solve it. That is 1 plus 1 2 plus a plus b minus 12 equal to 0. Now a plus b minus 10 equal to 0. Therefore, a plus b equal to 10. Now here, that is 2 square 4 plus 36 plus 2 times a minus 6b minus 12 equal to 0. That is 2a minus 6b, 4 plus 36, 40, 40 minus 28 is plus 28, that is equal to 0. Now we take 2 as a common. Now there is a minus 3 times b plus 14 equal to 0. Now that 2 is transferred to the right side, we get a minus 3b plus 14 equal to 0. Now here we can write a is equal to, well, sorry, b is equal to 10 minus a. Now put the value in the equation. This is equation 1, this is equation 2. Now we put this value of b in this equation. We get a minus 3 times b is 10 minus a plus 14 equal to 0. Now here the a minus 3 times 10, 30 minus 3a minus minus plus 3a plus 14 equal to 0. Now we can write it as 4a minus 16 equal to 0. That is, a will be equal to 16 over 4, and that is equal to 4. Now to get b, to find b, we put this value here. B equal to 10 minus 4, and the b will be equal to 6. The b is 6 and a equal to 4. Now to find the coordinates of the circle, we put this value in this equation. Now x squared plus y squared plus a is 4. Now that is 4x plus b is 6 plus 6y minus 12 equal to 0. Now to find the value of the center of the circle, there firstly we arrange the equation x squared plus 4x plus y squared plus 6y, that is equal to 12. Now we make the complete square of x squared plus y squared, that is x squared plus 4x, and the quotient of x is 4, we take the half. The half is 2. Now we take square 2 square, and we add 2 square on both sides. Here we add also 2 square, and y square is written as it is, 6y is written as it is, and we take the half of 6 is 3. Now we add 3 square on both sides. We get 3 square on both sides, and that equation becomes x plus 2 whole square, and that is y plus 3 whole square, and that is equal to is 27, and that equation can be written as x minus minus 2 whole square plus y minus minus 3 whole square. See, we check this value. 12 plus 2 square plus 3. Now here, sorry, this is the 12. This is 12. Now we get 12 plus 4, then 25. This is the equation of circle. This equation of circle. So this is the circle and this is the center. A, B is the center and X, Y is the point on circle. And that equation is x minus a whole square plus y minus b whole square equal to r square. So when we compare these two equations, therefore a and b, where a and b are the center, therefore minus 2 and minus 3 is the center of this. The part B, the equation of the tangent to the circle at point A, your answer in the form of Px plus Qy is equal to K, where P, Q, and K are integers. Now here is the circle, and this is the center point, and we already find the center of the circle is minus 2, 3, minus 2, minus 3, minus 3, and you know 1, 1. And 2 minus 6 lie on the circle already given in the question. Now suppose this point is 1, 1, 1, 1, and this line is the tangent to the circle. Okay. Equation of a line, that is y minus y1 equal to m into x minus x1. And this is equation y minus 1 equal to m into x minus 1. Now to find n of tangent line, gradient of tangent line, line that is equal to minus 1 over gradient of CP because radius is perpendicular to the tangent. Therefore, that gradient of tangent will be equal to minus 1 over gradient of CP because these are the lines are perpendicular. Therefore, now the gradient of this value, now find the gradient of CP here. The gradient of CP and of CP is equal to minus 3 minus 1 over minus 2 minus 1, 3, 4 over 3. Minus 4 minus 3 and 4 over 3. Now that gradient of tangent minus 4 over 3 and that is equal to minus 3 over 4. Now we put this value in this equation of tangent here. We see that for y minus 1 equal to m is minus 3 over 4 into x minus 1 and cross multiply 4 minus 4 that is equal to minus 3x minus 3x plus 1. This is 1 plus now next is 4x 4y plus 3x equal to 3 plus 4 that is equal to 7. This is the equation of tangent and we compare this px plus 2y equal to k. When we compare this here we see that 4 is equal to p, that p equal to 4 and same as when we compare this 3 is compared to q. Now q will be equal to 3 and k is will be equal to 7. This is the answer. Next question 9. The equation of curve is y equal to 3x plus 1 minus 4 times 3x plus 1 power 1 over 2 or x is greater than minus 1 over 3. Find dy over dx and d square y over dx square. Here y is equal to 3x plus 1 minus 4 into 3x plus 1 power 1 over 2. Now differentiate d over dy over dx to get dy over dx that is equal to 3 into differentiate of x is 1 and differentiate of 1 is 0 minus 4 times the differentiate of 3x plus 1. The power of this expression, it becomes coefficient of this expression and 1 over 2 into 3x plus 1 power 1 over 2 minus 1. Differentiate again this value, we get 3 into 1 plus 0. d over dx of f of x power n that is equal to n into f of x power n minus 1 into differentiate of f of x again. This is the formula here we apply. Now we were at the next step 3 plus 3 into 1 3 plus 0 3 minus 2 times 2 2 and that is 2 into and that is 3 into 1 3 that is we multiply 2 into 3 and become 3x plus 1 power minus 1 over 2. Now this value 3 minus 6 into 3x plus 1 power minus 1 over 2. Now the next step is that p square y my over dx square. We already find dy over dx. Now we find second is p square y over dx square. Now here b over dx and differentiate on both sides. dy over dx. We here differentiate to this. The 3 is with respect to x to 3 is 0 minus 6 into the power of this expression become the coefficient minus 1 over 2 into 3x plus 1 power minus 1 over 2 minus 1 and differentiate of this value again. We take the derivative of 3x is 3 plus 0, that is 3. Now this is minus 2 times 3 minus minus plus and 3 3 is 9 and that is 9 over 3x plus 1 power 3 over 2. And this is p square y over dx square. Find the coordinates of the stationary points of the curve mean determine its nature. To find the stationary point of the curve, now we already find dy over dx of the curve is here is 3 minus 6 times 3x plus 1. 6 into 3x plus 1 power minus 1 over 2. We have to find stationary point, the point where dy over dx will be 0. At this point, the curve will be at the maximum or minimum position. Now to determine the nature, uh, we we have to find d square y over dx square is greater than 0 or less than 0. Now d square y over dx square is already we have uh, found that value d square y over dx square. Now the value is 9 over 3x plus 1. 9 3x plus 1 power 3 over 2. Now firstly we find the dy over dx here. Now that is equal to 0, 3 minus 6 into 3x plus 1 power minus 1 over 2. Now that is 3 equal to 6 into 3x plus 1 power minus 1 over 2. Now we can write this as 3 over 6, 3x plus 1 power minus 1 over 2. That is 1 over 2. Now 3x, we can write this 1 over 3x plus 1, 1 over 2. Now we cross multiply 3x plus 1 over 1 over 2 equal to 2, taking square on both sides. We get 3x plus 1 equal to 4. Therefore, 3x equal to 3, x equal to 1. Nature of this curve, the curve is at maximum position or either a maximum or minimum position at x equal to 1. Now we put the value here, x equal to 1. Yes. Now put here, that is equal to 9 d square y over dx square, that is equal to 9 over 3 into 1 plus 1 power 3 over 2, that is greater than 0. Therefore, this is the minimum point. So is at minimum position at x equal to 1 because d square y is greater than dx square. You know very well this is the maximum point and this is the minimum point. At the minimum point, the second derivative it should be positive when the after the minimum point. So therefore, That is the minimum part. Now we go to the next part of the next question. Question 10. Function f and g are defined as follows. F of x, 2x plus 1 over 2x minus 1, 4x is not equal to 1 over 2, g of x is x squared plus 4, and 4x is member of R. Now the diagram shows the part of the graph y equal to f of x. Here this is the function of f of x. And the f inverse, domain of f inverse of x, that it will be equal to range of f of x. And the range of f of x. And we will find the range of the function f of x. We see that here in this graph. Now the values start from greater than 1. We see that the values of y are from 1 to infinity, and the values of the curve is going upward, and that is 1 to infinity. And same is this second below curve. If we see that the values of y is going downward, 1 to negative infinity. Therefore, the range of these values x is greater than 1 and x is less than 1. We can write it minus infinity to 1 and 1 to infinity, other than 1. Now we write it as x. The range of f will be equal to x is greater than 1 and x is less than 1. Now the next part. E part, find an expression for f inverse of x. Now here is f of x is given. That is equal to 2x plus 1 over 2x minus that. We suppose that f of x equal to y. Therefore, the x will be equal to f inverse of 1. Now we have firstly find f inverse of y. We make the subject x here. Now we multiply this 2 into yx minus y equal to 2x plus 1 to make subject x. We shift x toward right side. Now that is 2yx minus 2x equal to 1 plus 1, and we shift the y towards right. We see that here. Now we take the common. X is a common, that is 2y minus 2 equal to 1 plus y. That x will be equal to y plus 1 over 2y minus 2. Now x, we know the x equal to f inverse of y. F inverse of y and y plus 1 over 2y plus minus 2. Now we replace y by x, we get f inverse of x equal to x plus 1 over 2x minus 2. Now the part C, find gf of minus 3. Now we already the g of x is given above as x squared plus 4. Now firstly we find f inverse of 3. G of f inverse of 3. Now the f inverse of x is x plus 1 plus 1 over 2x minus 2. We put the value in this equation. Now this is 3 plus 1 over 2 times into 3 minus 2 into, and that is equal to g of 4 over 6 minus 2, that is 4. And that it will become g of 1. Now we find g of 1, that is g of 1 will be equal to 1 square plus 4, we get 5. In part D, explain why g inverse of x cannot be found. We know that the g of x is here x square plus 4. This is the quadratic function. And the quadratic function. In the quadratic function, the graph of the shape is just like this. On we see that this is the x squared plus 4 squared of the graph. To find the g inverse of x function is possible or not, we draw a horizontal line. When we draw the horizontal line, suppose that we draw a horizontal line, it intersects 2 points. Therefore, we can say g inverse is not a function because horizontal line passes through 2 points. Passes through 2 points. Okay. Now the part E, show that 1 plus 2 over 2x minus 1 can be expressed as 2x plus 1 over 2x minus 1, and hence find the area of the triangle enclosed by the tangent to the curve y equal to f of x at point where x equal to 1 and x-axis and y-axis. Please see here the y expression is given 1 plus 2 over 2x minus 1. Now we can write it. So taking the LCM, 2x minus 1 is the LCM. Now 1 times 2x is 2x minus 1 plus 2 into 2x minus 1 over 2x minus 1 is 1. Now therefore we get 2x minus 1 over plus 2 over 2x minus 1. We get 2x minus 1 plus 2 plus 1. 2x plus 1 over 2x minus 1. Next statement, find the area of triangle enclosed by the tangent to the curve at point where x equal to 1 and y axis. Now here is the curve. This is the curve, and we have to find the area of triangle enclosed by the tangent line at x equal to 1. Suppose this is the line x equal to 1, and we draw a tangent line. We will draw this line is x-axis and this is the y-axis. And the area between this triangle, now we find the area of the triangle enclosed by tangent x-axis and y-axis. Firstly, we have to find these 2 points, intersecting point, x-intercept and y-intercept. To find this x and y-intercept, we have to find the equation of tangent. Now the equation of tangent, here the function is given y equal to 2x plus 1 over 2x minus 1. We can write it as 1 plus 2 over 2x minus 1. And we have to find the equation of tangent. Now firstly we find the gradient. The gradient of this line will be equal to dy over dx, and that is equal to 0. And we know write 0 plus 2 into 2 over 2 into 2x minus 1. This is the 2x minus 1 power minus 1. Now we take this different derivative. Now we get minus 1 into 2x minus 1 power minus 1 minus 1 minus 2, and we take the differentiation. We take the derivative again. We get 2 into 1, and therefore the value become minus 4 times into 2x minus 1 power minus 2. Now we find the gradient at x equal to 1. Therefore x equal to 1 and dy over dx is to become minus 4 into 2 into 1, 2 minus 1, 1 power minus 2. And that value is minus 4. The equation of the tangent line, that is the value y minus y1 equal to n into x minus x1. Here y1 is we can find the value for this function. This is the y equal to 1 plus 2x 2 over x. Therefore y equal to 1 plus 2 over 2x minus 1 we can find when x equal to 1. Therefore, 1 plus 2 hour, 2 into 1, 2, 1, and that is 3. Therefore, the point at this point, 1, 3. Now, therefore, the y1 is 3 and m is minus 4 into x is x as it is minus 1. Now, solve this. We get y minus 3 equal to minus 4x plus 4, y equal to minus 4x plus 7. And to find the x and y-intercept, the y-intercept is 7, therefore 0, 7 is the point at y-axis, and when we put x equal to y equal to 0, we get 0 equal to minus 4x plus 7, and that is, and this value is minus 7 over 4. X is 7 over 4. The x-intercept is 7 over 4, 0. These are the points. Now 7 over 4, 0 and 0, 7. This is the 0, 7. 7 over 4, 0. And that point is 0, 0. Now we can find the area of the triangle by very easily. Now this is the base of the triangle. This is the base. Base is 7 over 4. This length is base. And this will be equal to 7 over 4. And the height is 7. Now area of triangle 1 over 2. 1 over 2 base into height. Here is 1 over 2 into 7 over 4 multiply 7. That will become 49 over 8. This is the answer. In question B part, use quadratic formula show that k greater than 5, the equation f of x equal to 0 has no solution. Now we put f of x equal to 0, that 4x cos 4x plus cos square x minus k equal to 0. Now we see that this is the cos square x whole square plus cos square x minus k equal to 0. Now we suppose that cos square x equal to t. Now we put the value here, that is 4t square plus t minus k equal to 0. T equal to, this is the quadratic equation and we use the quadratic formula. T equal to minus 1 plus minus b square, this is the b, 1 square minus 4 times, this is a 4, and this value is c, is k. Now we use the quadratic formula minus b plus minus b square minus 4ac over 2a, and 2 times of 4 is 8. Now we get minus 4 plus minus 1 minus 16, this is minus k, sorry, is plus 16k over 8. Now here k is greater than, k is greater than 5, therefore 16k greater than 80, and 1 plus 16k square root, that would become 80 plus 1 square root, and therefore as minus 1 plus minus 1 plus 16k, that is greater than, that is greater than 9, and we add minus 1 also here because 8 Therefore, minus 1 plus minus square root 1 plus 16k over 8, and over 8 we get greater than 1. Now we can write it. P is, if k is greater than 5, therefore minus 1 plus 1 plus 16k over 8 will be greater than 1. That is, and this is P, and P is greater than 1, and you know P is considered as cos square x, that is cos square x is greater than 1, and we know the cos x square x, the range of cos square x value is 1 to less than 1, oh sorry, less than 1 and greater than equal to 0. Therefore, that value is greater than 1, cos square x greater than 1 is not possible because the values of cos square within the range of 0 and 1.